see the objectives of this video on the screen. At the end of this video, you will be able to describe what is ABAP SQL and its new features, elaborate windowing in ABAP SQL. You will be able to explain the concept of hierarchies. You will be able to also describe what are the new data types introduced by SAP in ABAP. And you will be able to also describe how to create AMDP using graph type. So here you can see there are certain new features that SAP has introduced in ABAP SQL. Before going into new features of ABAP SQL, it is very important to first understand what is ABAP SQL. So now OpenSQL is renamed by SAP as ABAP SQL. So since in last decade, so maybe you can say since 1809 or 1909 version, now SAP says that ABAP SQL is SAP OpenSQL is now called as ABAP SQL. So whatever activities you do or whatever SQL statements you write in ABAP program, those are called as ABAP SQL. So what are the features of ABAP SQL? So you can see first feature is CTEs, that is common table expressions. Basically common table expressions are used to help you to write more complex queries. So whenever you are writing complex queries, it is a set of small queries or subqueries. In order to simplify these complex queries, you write a set of subqueries, and these subqueries can be written using common table expressions. You can store the result of these subqueries into a CTE. So a temporary storage can be created within a SQL statement with the use of CTEs, and then you can also use hierarchical data using CTEs. So you will be able to see a separate video for CTEs, how to use CTEs and how to write ABAP SQL using CTEs. Then another feature that SAP has introduced is some new inline declaration syntax, which you are going to learn in this video. There is a concept of windowing in ABAP SQL, which you are going to learn in this video itself. Then you can have hierarchies in ABAP SQL. So this also we are going to discuss in this video. And then there are some new ABAP data types that SAP has introduced that also we are going to discuss in this video. So to begin with, you can see the first feature is inline declarations. I hope you must have already gone through, or you must be already using some basic inline declaration concepts wherein you can use host variables to ensure that you need not declare variables or internal tables while using your select statement. So here is an example which you are already familiar with. Select char id con id from SPFLI into table add data LT data. So here in this case, since you are using ATCH data, you need not declare internal table. The system will declare internal table at runtime depending upon your select statement. So this inline declaration you are already familiar with. However, in this case, if you are using LT underscore data internal table, this internal table cannot be used as a type. For example, if I want to declare another variable of type LT data or a type reference to LT data, it is not possible in this case. So SAP has introduced another syntax for inline declaration. So here you can see second example, select char id con id from SPFLI into table new add data LT data. So this new addition is there in the select statement. With this addition, now LT data will be created as a separate data type which you can use for declaring any other variables. So you can declare with now any other variable saying type of LT data. So this is a new addition which can be used in your inline declaration syntax. Another way is, or another new syntax you can see over here is modify SPFLI from table at value hash char id equal to some value and con id is equal to some value. So in this case, what the system is doing is the system will be creating two local variables char id and con id at runtime, and these local variables will have some hard-coded value that is given in the modify statement. So in this case, char ID and con ID will be two local variables which will be created at runtime, and these two variables will have existence only at runtime. After this modify statement, you cannot access char ID or con ID explicitly. So these two variables will be created at runtime. Char ID will have hard-coded value 0018, con ID will have hard-coded value 008. So this kind of new syntax is possible to now write. So in this case, these two char ID and con ID values will be updated in SPFLI table. So this syntax can be used with insert, modify or update commands. Now along with this inline declaration, SAP has also introduced one more concept, that is windowing in ABAP SQL. What do you mean by windowing? If you take English meaning of window, that means if you are looking through a window, you can see a specific area from the outside. So the same concept is applied over here. If you are creating a window, then that means actually you are looking at some subset of your data. You are picking up some subset of your data and then you are doing some aggregations or calculations on top of it, or you can say you are doing a grouping and then doing some calculations on top of that window. Say for example, if I have a sales order data and name of my table is Z sales item, and if I have 4 columns in this, I have order number, item name and price. Now here you can see there are actually two orders. One is order number 100 with 3 items and order number 101 with 1 item. So suppose this is a data from one of the consumable product company and they want to understand what is the sale of their consumable products in each order. So for example, in order number 100, there are 3 products, 2 toothpaste and 1 shampoo. So they want to understand what is the percentage of toothpaste and what is the percentage of shampoo in that particular order. So in that case, you can create 2 windows, one window for order number 100, another window for order number 101. And now if you want to calculate price per total, what is the percentage of first item, that is first toothpaste 21000 over the complete order number, then you can see it is 21.73%. How you calculate it? You calculate the sum of price, that is 2300, and out of that how much is the percentage of this toothpaste, that is 21.73. For the second item it is 13%, for the third item it is 65.21%. And obviously for the second order, since it is only one item, obviously the percentage will be 100%. Now if you want to write an SQL statement with this, you can say select from Z sales item as items, fields atom star, so it will select all the fields. Then you can say price divided by sum of price as total over partition by order number as average percentage into table add data IT data. So here you can see sum of price is a normal aggregate function. However, you are creating a window using this syntax over. So when you say over, it is creating a window, and you say partition by order number. That means you are telling the system to create a window according to order number field, and that is why it will create two windows, one window with order number 100, another window with order number 101. Then it will calculate the sum of price within that window and then display it, calculate the average and display it under average percentage. So this is how it will work, or this is how you can create a window and then you can calculate the percentage, or you can do any other type of calculations. However, in this case, I am not creating any group. Say for example, in this case, there are two atoms with the same name. However, I haven't created grouping and I haven't clubbed this. So as a next step, or in any other scenario, if you want to do the grouping within window, that is also possible. Say for example, if you take the same table, order number, item name and price, same table, and now if I create a grouping, then it will look like this, wherein now I have two records within first order number 100, wherein I am clubbing the cell or the price of items toothpaste, so it is coming as total 500 plus 300 as total 800, and then next atom as shampoo, and then next, or you can say the second order number. So here now if I want to calculate price by total, so what is the percentage of this atom over the complete order number? It is coming to 34.78, and here if you see for the second atom, obviously it will be same 65.21, and the third, that is the order number 101, again it will be 100%. Now if I want to write a select statement as per this scenario, how the select statement will look like is: select from Z cells atom as atoms, fields order number atom name, sum of price divided by sum of price, over partition by order number as average percentage, and group by order number and atom number into table IT data. So now in this case you can see sum of price is used multiple times. Why it is so? So here you can see the inner sum of price is related to grouping, because since I am doing a grouping over here according to order number and atom name, and I want to calculate the sum of price as per my group also, and that is why I am using this sum of price in the inner bracket, and this outer sum of price you can see that is related to partition, which I am using over here as order by or over partition by order number. So this outer sum is related to the partition or the window which I am creating as per order number. And then finally I am saying group by order number and atom number. So in this case what you are doing is you are calculating the sum of price as per by doing the grouping, and that is why you need a sum of price inside the bracket, and then again you are calculating the sum of price as per the window, so you also need sum of price in the outer bracket. So that is why you need to use sum of price 2 times, and then you give the window, you say over partition by order number, and then you say group by order number and atom number. So this is how you can use windowing concept in ABAP SQL with grouping or without grouping, depending upon the usage or depending upon the requirement. The next concept in SAP ABAP SQL is creating hierarchies. So this is nothing but which will help you to create a self-association, or which will help you to create a tree structure. For example, if I want to create a hierarchy of relationship like employee or manager relationship, I can create a hierarchy using ABAP SQL. In this case, what will happen is, suppose I start creating a hierarchy of employee and manager relationship, wherein there will be first MD, which will be the root MD, and then under MD you can have a senior manager which will be reporting to MD. Under senior manager you will have a manager which will reporting to senior manager. There will be an employee reporting to manager. So like this you can create a tree of relationship, and this way you can use it in your ABAP SQL, and you can also use these kind of hierarchies in CDS views. You can use these hierarchies in ABAP SQL using cities also by using a clause using associations. For example, if I have a table over here like entity, parent and quantity, here I can say that there is an entity cat and quantity 1. Each cat has 4 legs, so next entity is leg. The parent is cat and quantity is 4 because each cat will be having 4 legs. And then the next entity is nails, which the parent is leg because each leg will have nails, and each leg has 5 nails. So you can see over here this is a parent child quantity which is created. So the parent is cat, then you have leg which has parent as cat, then you have nails which has parent as leg, and this is how you can represent a hierarchical relationship. This topic you will learn in another video. Then SAP has also introduced some new data types. For example, you can see DEC float 16 which has been introduced in ABAP, which is a decimal float point with 16 places. Similar to that, you also have DEC float 34, which is a decimal floating point number 34 places. Then you have another important data type in ABAP, that is UTC long, which will help you to represent UTC timestamp field. Then you have daten field which is introduced newly in ABAP, which is nothing but similar to DATS field or a date field. You also have time n field in ABAP similar to time field, which will represent time in ABAP. And you also have one more new geometric data type, that is GEOM underscore EWBK. So basically SAP has introduced these new data types in ABAP in order to map corresponding HANA data types into ABAP data types. For example, in ABAP you have DATS for date. However, in HANA it is DATN. So you need something, or you need to have an integration between HANA data types and ABAP data types, and that is why SAP has introduced these new data types in ABAP, so that you can have integration of HANA data types in ABAP. So DATN and TimeN are basically HANA data types which are again introduced for integration in ABAP. And in HANA also you have EWKB data type, or you have EWKB representation in HANA. For that SAP has introduced GEOM EWBK data type in ABAP, which will help you to represent geographic data in ABAP, which is already there in HANA data type. So this is what is a new addition for ABAPers. These are the new data types which are introduced by SAP to map corresponding HANA data types into ABAP data type. So the question is how you use these data types. For example, this is a simple table which is created, which has a couple of fields like road number, large road size, small road size, construction date, and change log. Now here you can see different ABAP data types are used in this case. So you can see for L road size the data type is DEC float 34. For S road size it is DEC float 16. For construction date it is DATN, and for change log it is UTC log. This change log you can see this is a date and timestamp. So this is how you can create a table using these new data types in ABAP. And if you want to write a select statement on top of it, this you can see over here how you can write a select statement. It is a normal way, the way you write it normally. Select road number, L road size, S road size, construction date, change log from 0 data into table, add data, rd underscore data. So this is a normal way how you will write a select statement on top of this. Now apart from this, SAP has also come up with conversion functions for these new built-in data types. So for example, now you have date types, you have DATN and DATS. So obviously you need conversion functions for both data types to convert both the data types. So you have DATN days between, that means to calculate the difference between dates using DATN. DATN add days if you want to add days, DATN add months if you want to add months. And obviously if you want to convert DATS to DATN, or if you want to convert DATS from DATN, you have these two functions. Similar to that, you have time functions. If you want to convert times to timen or times from timen, you will need these conversion functions. And then there are some UTC functions which are introduced for conversions, like UTCL current to get the current timestamp, UTCL seconds between, the difference between seconds between two timestamps, to UTC timestamps, UTCL add seconds if you want to add seconds in a UTC timestamp, TSTMPL to UTC, or TSTMPL from UTCL. So if you want to convert from TSTMPL to UTCL or to and fro, you can use these conversion functions. So SAP has introduced data types, graph data types in ABAP. That is what you have learned in previous slide. Say for example, in HANA database you have a graph data type, that is ST underscore geometry. And for this ST underscore geometry, SAP has introduced new data type GEOM underscore EWKB in ABAP layer or in ABAP platform. This data type you can use in data dictionary. That means if you want to create any database object, data dictionary object through data dictionary in ABAP, you can use this data type, which will represent ST underscore geometry data type in underlying HANA database. The same data type is used in ABAP language as Xstring. And then once you create your database object with this type GUM-EWKB, you can use that object in your corresponding ABAP artifact or HANA artifact, like it may be SQL statement or it may be your CDS view. So this is how it works, that HANA database type ST geometry now can be used in ABAP as GUM-EWKB, and you can use it in ABAP SQL or CDS views. So if you want to, however, if you want to convert this into HANA data types, then you have to use AMDP for the same. So here you can see that this new geo data type GUM-EWKB has been introduced, which can be used in data dictionary and which can be used through CDS view and ABAP SQL. The important thing is this data type GUM-EWKB is used for just allowing front-end systems to use HANA data type SD geometry. So there is no specific semantics which is added in ABAP language for GUM-EWKB, because this GUM-EWKB will just allow you to expose HANA data type for the front end. So this is nothing but just allowing the front end to use HANA data type. So ABAP platform will help you to use underlying HANA database type in the front end. And then you need AMDP to access this geo-specific functionality, so AMDP that you create in ABAP layer, which can be used to access this functionality. What I mean by that, for example, suppose I create a table over here. I say define table zgeo_customer, and I create this table using this ABAP type GEOM_EWKB. So what I do is I create certain fields. First field is ID of type ABAP info, customer name of type ABAP.char30, cell of type ABAP.dec152, and then I create a field location of type ABAP.GEOM_EWKB. Now in this case you can see GEOM_EWKB, this is a geo data type, and for this geo data type I am giving a reference spatial reference system. So what is this spatial reference system? This is nothing but similar to your currency field. For example, if you create a table in data dictionary and if you create a field of type currency, you have to give a reference of currency key for that field. Similar to that, when you create a geodata type field, you have to give a reference of spatial reference system. What is the meaning of this? This means that how you are going to calculate the distance between two spaces. So are you going to say that whether you are going to consider it as a flat earth or a round earth, or what kind of system you are going to use to calculate the distance between two places. And this is 4326 is a standard international system which is used in your GPS system also. So 4326 is a standard system which is used in GPS, and the same system you are going to use in this geodata type also. So whenever you use this geodata type, you have to give the reference of corresponding spatial reference system. So this is how I create my table. And now if I want to create a select statement with this table, I can write a select statement like select ID, customer number, customer name, sale, location from ZGO customer into table add data LT customer. This is a normal select statement. However, if you see the output of this select statement, you will be able to see something similar to this. First column is ID 1 2 3 4, then customer name, then sale, and in location field you can see there is a binary number which has got generated. So in this case it is very difficult to understand what is the meaning of this binary number. To convert this binary number you need AMDP. To convert this binary number into actual location, you need AMDP, and that is why in the previous slide you have learned that you need AMDP for the conversion of this geo-specific data type. So how you use AMDP in this case? So for example, I create a structure which is similar to my table ZGO customer, and the same fields ID, customer name, cell and location with the same type, geospecific data type, and I also give the spatial reference system, that is 4806, which is a standard international standard for GPS. And based on this structure, now I create my AMDP. So my AMDP class name is ZCL_geo_type, and I implement a standard interface if AMDP marker HDB over here, and then I define types over here, types TT customer, type standard table of ZGeo customer, and then I define my method, class methods, that is a static method, get data, importing value as IVID type int4, and returning value as ET customer type TT customer. Now I implement my method. So I say method get data by database function for HDB, language SQL script, options read only, using ZGeo customer and ZGeo highway. So in this case, I will be using two database tables, ZGeo customer, which I have already created, and ZGeo highway. ZGeo customer will give me the customer details, customer data, and ZGeo highway will give me the data related to a highway. Highways, what are the different highways and what is the length of the highway, what is the distance between highways. So this information is there in the highway. Now what I want to do is I want to check which customers stay within 100 kilometer of particular highway. So how can I write a select statement for that? So here you can see return select ID, customer name, cell, location from ZGeo customer as cust, where boundary.st covers into bracket cust location from ZGeo highway, where ID is equal to IV state ID equal to 1. So this boundary.st covers is a SQL function. This is a HANA SQL function which is introduced by SAP. So you can see this is a new function in SQL, in HANA SQL, boundary.st covers, which will help me to understand that I am saying that boundary.st covers of customer location where the ID equal to 1. That means I am saying I want to understand which customers are there within a boundary of 100 kilometers from customer location. So this is how I can find out the customers who stay within 100 kilometers from that particular highway using this select statement. So these are the new SQL functions which are introduced by SAP, and you can learn more about this HANA SQL functions in SQL function guide, which is published by SAP. And then if I want to consume this AMDP, then how it can be, you can write this kind of statement, data into bracket LTCust is equal to, this is my class name ZCL type, and the method I am calling get data, and then I am passing the variable, the parameter IVID, I am passing 1004 as the value of my IVID. So this is how you can consume this AMDP method, the way you consume it normally in your program or in maybe in any other AMDP method. So this is how you can create, and this is how you can use graph data in ABAP SQL, and how you can use AMDP for selecting the data or writing select statements using graph data, and this is how you can consume this AMDP in any ABAP program or in any other ABAP AMDP method also. So all the best, please go ahead, and you can, using this knowledge, you can explore more and you can understand new features in ABAP on HANA. If you need any more help related to these new features, you can also check the reference links which we have given in the training material, or you can also contact LKM SMEs to get more information about this.